Good afternoon. Welcome to our graduation ceremony for 2015. We're delighted to have everyone here, students and family. I'm Cliff Pollack. I'm the department chair, so to speak, and it's my honor to run the ceremony. This is probably the happiest day in Ithaca. I think it's more happiness per square foot in this location than any place else on earth. It's an exciting, fun weekend. Technically, we're here to honor the students. We will. But honestly, the reason this is a great day is because of the families who've come. We have people who've come from all around the world to join us. And you are the reason this is a great celebration. According to my list, we have people from Canada, China, India, Indonesia, Iran, Japan, Jakarta, Korea, Lebanon, Malaysia, Nigeria, Singapore, Taiwan, Vietnam, USA, and even Texas. We're really happy to have you here. That's what makes this such a good day. Let me introduce the faculty. Those are the ones who've been doing the heavy lifting here. So I'll just quickly run down. Peter Dorschik on the end. So anyway, tomorrow is a spectacular day. There's going to be a stadium full of people in color and pageantry and great speeches and processions and music. That's the official graduation. That's when you officially become a Bachelor of Engineering, Bachelor of Science. Today we're here more just to celebrate. This is a small group. We're going to talk about electrical engineering students. We want to celebrate the students, have fun with them, and really just enjoy what they've done. You're not going to get a serious speech with advice and all that kind of nonsense. You can get that. You can get one on your smartphone right now. I'm sure download it, or you can see it one tomorrow. So we're here just to have some fun. So students, graduates, you finally made it. It's been 4 years. You've been working hard. You spent hundreds of hours in 314 in that little lab thinking, could there be a seat in your room? And you've survived. You've done a lot of great things. Some of you learned how to make transistors from scratch. Some of you made Pong games which work on brainwaves. You've built lots of projects. Every guitar game that you made, and there were a lot of them, there was also a device which assisted handicapped people. Now, all these things are useful. All these things are part of the education. All of these things are founded on fundamental knowledge, which you've learned over these 4 years. You've learned Fourier transforms, solid-state electronics, pipeline instruction code, Gaussian noise, Maxwell's equations, probability, Kirchhoff's law, even the ABCD law. All these things are part of a very big foundation that you've absorbed in the last 4 years. This is knowledge which has been generated for more than a century. And in 4 years, you've absorbed it all. It's an amazing feat you've accomplished. So to the friends and family of the graduates here, I want you to know we really worked these students hard. If they called you up and said they were working hard, they were understating the situations. We really have a tradition here of working people through a rigorous program. They learn a lot, they learn how to solve problems, they learn how to work hard. And that's one of the foundations of our degree. Everyone in the world knows this. So you graduates, you're now part of a very prestigious and elite group. You're a Cornell engineer. There's always been a tendency, like an institution, to pat itself on the back and say, well, you're special. But, in this case, it's true. You're special. This is a great place. The Cornell degree, Cornell started 150 years ago. It was a land-grant institution. And back then, there was a big need for a nice, growing country. They needed people who could work and solve problems. So the land-grant institutions were formed. Cornell was New York State's land-grant institution. We had agriculture, and then mechanical arts, and engineering. It was part of our beginning. It was part of the needs of the nation, and that's what we did. We were the very first school, very first university in the world to have electrical engineering. 130 years ago today was the first graduation of EE. So you're joining a group which is quite long, great history. No one else has the history you have. This is a great place. So, how did we get here? Well, today is May 23rd. Tomorrow, obviously, is May 24th. On May 24th, 1844, Samuel Morse stood in the Supreme Court chamber of the Congress and demonstrated the first telegraph. I've got a picture of it here. There's a picture of what this is right here. You're probably wondering, what is this thing? This is the ugliest centerpiece you've ever seen, right? This is the very telegraph receiver which Morse used to receive that very first message. And so on that day, we walked over. This has a paper feed. So the mechanics were made on paper. Here's a piece of paper. He flipped this lever, and that started this gear working, and now the paper starts feeding out. And then 60 miles away, in Baltimore, his assistant had this key and typed in this famous message. I'll try and do it. That's what? A little ahead. Oh, wait, just a second. So the next word is God. And with that, that's 35 seconds. This message was sent. In 35 seconds, they sent this message, which could have gone, it would have taken probably 8 to 10 hours to travel from Baltimore. Here it was. This was a new age. The world changed at that moment. We went from travel at the speed of a horse, communication at the speed of a horse, to communication at the speed of light. It was an amazing breakthrough. And things haven't been the same since. So, this was quite an event. So you're probably wondering, what the heck are we doing with this piece of equipment here in Ithaca, New York? Turns out, the person who ran the wires, and this was wires, these are telegraph wires, was Ezra Cornell. So Ezra Cornell put the wiring in. He was the first lineman, if you will, in the world. And got this thing operating, and he was so impressed by this. He was also a businessman. He saw the opportunity, so he started forming telegraph companies. And here's an example of an old telegraph we found. Notice it's got a bunch of names in the Cornell line. So everyone is practically putting up Cornell or telegraph lines around the world. So Cornell went out and put them all together. And he formed Western Union. And he made the first telecommunication company, much like Verizon or AT&T is today. And with that, he started the whole telecommunication industry. This was very popular. Everyone liked it. It was an exciting time. And what it demonstrated was that, what I find amazing about this is, this was the very first one, 171 years ago. It was digital. It was binary. Information traveled at the speed of light, as it does now. It could form a global network, as we have now. It improved people's lives. People loved it. People still like communication. And it made a lot of money. And that's why we're here today. Because he made an awful lot of money on this thing. Here's a picture of a statue. And if you notice the back, this is an arts club. On the back of the statue right there is the telegraph. So if you ever look at that and wonder what that thing is, that's the telegraph. That's where he made his fortune. And so he endowed this university. So we're here today in Ithaca because of this thing right here. And that's pretty cool. Now there's more to this story. So this was a cool thing. And so people loved communicating and they'd like to go across the ocean. So the transatlantic cable was put in. Because, traveling a message across the ocean was months. If it could be done instantly, that'd be great. So they put a new line in, and it lasted about a week and then failed. It cost about $1 million, and the investors got really ticked off. And they said, we're going to sue. And so they formed a committee and started looking into it. So Lord Kelvin, who's a famous scientist, was called in to look at this whole system. And he realized that there was no standard. There were no standards at all for electricity. They didn't know what impedance was, conduction, all that stuff. So they formed the standards. We noted volts, amps, ohms, farads, henries. All of these terms, which you students know very well, you all learned in the 2100. That all came about because of the needs created by this machine. Electrical science was born because of the needs for the telegraph. So out of electrical science, then sprouted up universities. Cornell in 1883 was the very first university to form this electrical science degree, electrical engineering. MIT created one as well. In 1885, the first graduates. So that's the second reason we're here. And that's why we're here at ECE, because this thing spawned the need for the knowledge that you all have learned in the last 4 years. So a tremendous amount of stuff happened. So we were formed originally in Franklin Hall, which is now Chotton Hall. If you walk over and look at that, it's by the Art Museum, you'll see little figurines of Franklin and Volta and all those guys. It's really cool. So anyway, it all started here. Now, of course, that was a long time ago, 130 years ago. Things have not slowed down at all. The neat thing about electrical engineering is that it's an exponentially growing field. Every year the knowledge expands and gets more and more and more. For example, this thing operated about 1 bit per second in common parlance. Within 10 years, there were 20,000 miles of telegraph. By the Civil War, these things were being put in as armies advanced. It was just the main way for communication to happen. It was just a real-time communication line. Rapid communication was not impossible, it was expected, it was determined. And today, telecommunication networks form a major part of all of our lives. We still send things digitally, a bit at a time, but we send 10 to the 12th, a terabit of information a second, not just 1 or 2. This changes the world and continues to. Lincoln used this to win the Civil War, but today presidents use it for selfies. So here we are. Where we've gone in this whole thing. So every one of us, here's a cell phone, every one of us effectively has a Morse receiver in our pocket. There's no difference between that and that except the bandwidth that sends more information. But it's a very fascinating device. That's exponential growth characterizes where we've been. I want to explain to the students that's where we're going. Exponential growth is fun. Someone makes a transistor. It's pretty cool. We make a little amplifier out of it. And someone says, well, I can put a couple of those together, make an integrated circuit, make an op amp. Someone else says, oh, if you can put those together, I can take all my digital circuits and make a LSI logic. Well, if you can do that, then we can put them together, make a little microcontroller. And, well, what the heck, let's make a computer. Oh, you're doing that, let's digitize everything. So instead of music, we'll have CDs. And pretty soon this leads to other things, and now you can hear a pin drop on the telephone. And this just keeps advancing, and pretty soon you've got the internet, and all sorts of things are happening. And then you've got cell phones. It's just this non-stop progression, and it's not going to stop. So it's been a tremendous amount of where it's going, and it's going to keep going. So to the students today, you're standing at the base of this exponential curve. You're at the base of what's going to explode in the future. And you're going to be riding with it. So isn't it nice to be on the base right now? Didn't have to wait too much longer, but it's going to be exciting. So there's a lot of stuff still ahead of you, and it's going to be fun. So anyway, this is one thing we have tried to equip you with. We try not to teach you technology, we try to teach you knowledge. Fundamentals which are timeless, and which you can build on, and which you will build on, because that exponential growth is going to come from the contributions you make as well as others. So it's kind of fun to think about exponential growth. If we look projecting forward, where are things going? So let's look forward 40 years ahead. Things are going to expand a lot. So I looked at some situations around the school. So here's one I started with. So here's one of our students, Asher Novak. And he's demonstrating, classic control theory here. Only an electrical engineer can do, right? Well, let's go 40 years ahead. Where's Asher? Asher's out there somewhere. There we go. So 40 years from now, here's what I expect, Asher. You're going to, if we exponentially expand this thing, you're going to do much bigger things. We're going to have a Chrysler building on your ship. So that's kind of what happens in 40 years. Here's another one. Here's our ECE day. We had a dunk tank. So there's Professor Scooter being a good citizen, getting dunked by one of the students. A lot of fun. We're only going to do this for 40 more years. Because at the end of 40 years, here's what it will look like in the same sea. The oceans will have risen, and we're going to have a beach right there. We just won't need to do this anymore. So things are 40 years is a lot of time. Here's one. Here's another event we had. One of our classes gets to build a robot and microcontrol it, and then use radios to compute how to take it through a maze. And so here are the students setting up their robots and mapping out the maze, and that's really nice. So some of you have probably read Ray Kurzweil's books. He's a futurist. He likes to talk about how computers are growing in intelligence and power, and someday we're going to reach a singularity. I think it's in 2045 or something, where computers are now sent, they can think on their own. They start to have a mind of thoughts. So that's not 40 years away. So I think 40 years from now, we're going to see this. We're going to see a computer running some poor stupid through a maze, driving us crazy. So it's pretty scary. What's going on here? Anyway, that's what's ahead. Here's Phillips Hall. This is taken outside from across the street by Gates Hall. So what's going to look like in 40 years? This picture was taken in front of the new Gates Hall. I wish this wasn't true, but I think it is. So we'll see. Anyway, so that's some of the stuff. So I was cruising the web the other night, and I was looking up, there's a site that said it had the 10 best degrees to get. So I wanted to see where we fit. I couldn't quite find it, but I found the top degree was this picture. What's wrong with this picture? What's wrong with this picture? Have you ever seen a computer science major lecture? Listen, this is us. We're the guys who make this kind of stuff. We're the ECEs. We come out of the clean room, we build the chips, we make it all work. We make bits happen. And so I thought this was kind of a rip-off. I mean, I think to be fair, and to be unfair, I think what a computer science picture would have is somebody singing from a computer with frustration because you have a curly bracket instead of a parenthesis someplace. Trying to find this thing out. Didn't like that. Anyway, there's a lot of stuff going on here, and it's a lot of fun. So let me just say a little more about software. I think software is certainly taking things over in school. We are starting to add that to our curriculum, and it's going to be an increasing part of what we. What's going on here? No, my phone is talking. Oh, jeez. My phone and telegraph are talking to each other. It's like the sentience is happening. I guess a little too early. Jeez, what's going on? I'm going to turn you. There we go. Enough of that nonsense. So this just goes to show you know that the guy who controls the electrons controls the brains here. So I don't care if you get any ECEs are in control. We'll make things work. So a major piece of every education, when you graduate, you have to have some sort of oral exam. The person writing a dissertation is to stand up in public and defend it. And so I think this is important for our degree. Here's the public. We're here. You really haven't had that oral exam yet. I think it's time for that. So we're going to do this. If you guys pass, you okay. If not, let's think about it. So here's my first question. And I'll call it out. Anybody can answer it. This is pretty simple. I'll start with some electromagnetics. So who can tell me what the impedance of free space is?
377.
377 what?
Ohms.
Ohms, good. Okay. Okay, what does that impedance mean?
The ratio of electric to magnetic field.
Ah, that's right. Very good. Okay, here's a little tougher. How about this? Okay, how far does light travel in 1 nanosecond? 29.975. Was that 29.97? That's exactly right. I was going to say about a foot. Oh, well, good for you. Okay, what else I got? Let's go with some more challenging. Okay, here's one. How many additions per second can a dual issue 4 gigahertz processor execute? 8 million. Very good. 8 million is right. You guys are sharp. All right. Okay, here's one. Are computers smart or are they dumb? Got that. And why is that?
They need to be told exactly what to do.
Yes. Okay. Every time I think about that question, it makes me pause for a minute. The men will appreciate this. If you're married, doing exactly what you're told to do is a smart thing to do. So we're not computers, obviously. Okay, more communication. How fast does one need to sample a 20 kilohertz signal? 40? 40 kilohertz, okay, good. Okay, here's a fun one. The Morse receiver wants to get involved here. So we're going to ask a question Jeopardy style. All right? So here's the answer. Oh, I forgot. You're the video generation. Okay, here's the question. Anybody?
What is the complexity of the FFT algorithm?
Yeah. Wow, good for you. Can you read Morse code? Okay, here's a n-log n is the question. That's the answer. Okay, very good. I know. Here's one. Everyone will get this. What signals are eigenfunctions of linear time invariant systems? Complex exponential. Who doesn't know that? And let's see. Okay, try one for a closer here. What's the energy level of the upper state of the red helium neon laser line? Ah, who said that? Ah, very good. Good job. Okay, so we're there. So that was a little tough. Sometimes we need a little help. Anyway, I think that's the end of the exam. What do you say? Were they? Congratulations. Well, you guys have been fantastic. We have really enjoyed having you as students. The class has been delightful. Everyone who enjoys teaching loves it here. You've just been a great class. You learned how to work hard. You've got good spirit, you have a good sense of humor. You know how to manage your time. You learn how to solve problems. It's going to pay off big. You can get a little bit of sleep. There are times in life when you sometimes won't know the answer to something. There's a lot of people out here who will support you. You know, if you have a question, just ask. Everyone's rooting for you. So you've got a long, healthy, happy future ahead of you. We're just glad that you're a part of it here. So, class of 2015, best of luck. Congratulations.